Let's do part A. That is, we have to sketch the position function R of t. We have this position function R of t, which is given by t minus 1, comma 2t squared plus 3, comma 0. So from this position function, we can identify the coordinates. That is, x of t is given as t minus 1, and y of t is given as 2t squared plus 3, and z of t, and this equals 0. So looking at these three coordinates, we see that z of t is always 0, and this means we have only the 2 points described by these equations, that is x of t and y of t. And this means the when we do the sketch of the position function, is basically going to be a sketch on the xy plane, only on the xy plane, z equal to 0. So all that we have to do is we have to collect the points and plot the points on the xy plane and connect the points. So let's do that. So if you look at this table here, I have already created the table where I have taken few sample values for t and substituted each of the sample values in these two equation for x of t as well as y of t, and thereby I got this table. So these are the points that we are interested. That is, we have the point negative 5 comma 35, and then negative 4 comma 21. So likewise, we have some sample points which we can plot it on the xy plane and do the sketch. Okay, here I showed the sketch of this function r of t after plotting the points from the table. We have this point. This point is negative 5 comma 35, and we have another symmetric point, that is 3 comma 35. And likewise, I have plotted all the points. That is, this point is negative 4 comma 21, and the symmetric point is 2 comma 21. So likewise, we have the other points, this point as well as these two symmetric point, and this one. Basically, this represents the vertex of this parabola. The sketch of this position function r of t, this is basically a parabola. This is on the xy plane which we have plotted. So this is the sketch of the position function r of t. Let's do part B. Here we find velocity function and acceleration function. We write velocity function, that is v of t, and this is basically the derivative of the position function, that is written as r prime of t. So let's find r prime of t. So for this, we find the derivative of the r of t. So we have to find the derivative of each of the components inside the bracket. So I put this as a bracket. The derivative of t minus 1 with respect to t is 1, and the derivative of 2t squared plus 3 is 4t, because the derivative of 2t squared, we can say that 2 times of derivative of 2 t square is 2t. So therefore 2 times 2 is 4, and this becomes 40. So that's why I have written 40. And then we have 0. So this is basically the velocity function. V of t equals 1 comma 40 comma 0. Now let's find the acceleration function. So we write acceleration function, and this equals, it's basically the derivative of the velocity function v prime of t, or otherwise we can also say that it is the second derivative of the position function. So we will now consider this velocity function, and we have to find its derivative. So I write a of t, and this equals, we have to find the derivative of each of the terms inside the bracket. So the derivative of 1, which is a constant, is 0, and the derivative of 4t, we put the 4, and the derivative of t is 1. So it is 4 times of 1 is basically 4, and then we have this 0. So this is the one which represents the acceleration function. In part C, we find the unit tangent vector. So I write down this unit tangent vector shortly as UTV, and this equals r prime of t divided by the magnitude of r prime of t. So this is the formula which we utilize to determine the unit tangent vector. So we can utilize the r prime of t which we found in part B, and we will also have to find its magnitude. So first let's determine the magnitude of r prime of t, and this is given by square root of sum of the components, square of the components. So it is 1 square plus 4t quantity squared. I take each of the terms inside the bracket and square them up and add them together, and then 0 squared. So this basically gives 1 square is 1, and square of 4t square is 16t square, because the square of 4 is 16 and square of t is a t square, and plus 0 square, which is 0. So basically we get this expression 1 plus 16 to square under the root. So we can substitute this into the formula. I put this r prime of t in bracket form, that is 1 comma 4t comma 0, and this divided by the magnitude of r prime of t, which we found here, that is 1 plus 16t square. This is under the root. So we can write down in the complete component form, that is we have to divide each of the components in the numerator by this by this quantity 1 plus 16t square under the root. We can rewrite this as 1 divided by 1 plus 16t square under the root, comma, the next term is 40. So 40 divided by 1 plus 16t square under the root, comma, 0 divided by the same quantity is 0. So you can just put this as 0. And this is in, we have written this in the component form. So this is the unit tangent vector.